On This Week in Enterprise Tech, the bots are coming, Foxconn is here, eh? And your next sequel might be NoSQL. TWiET on the set.
Netcasts you love.
From people you trust.
This is TWiET.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is TWiET, This Week in Enterprise Tech, episode 257, recorded September 15, 2017. Couchbase. What database is right for you? This Week in Enterprise Tech is brought to you by Drobo, a family of safe, expandable, yet simple-to-use storage arrays. Drobos are designed to protect your important data forever. Visit drobostore.com to learn more and use the code TWiET10 to save 10% off select Drobos, including the Drobo 5N2 and 5D3. Welcome to TWiET, This Week in Enterprise Tech. It's the show dedicated to the enterprise professionals, the IT pros, and the geeks who just want to know how the world is connected. I'm your host, Father Robert Ballas, the digital Jesuit, your guide to all things in the enterprise. But I can't guide you by myself. I'm going to need a little help, starting with Mr. Brian Chi. He is the director of the Advanced Network Computing Laboratory in Honolulu, Hawaii. And yes, folks, he is still melting into a puddle of Hawaiian goodness. Chibert, how hot is it in your lab right now?
I think we're running at about 83, 84, so
Ouch.
Not horrible.
Ouch. But you can't open up your data center with the air conditioner without blasting our audience with noise.
Roger that.
Okay, well, we're going to try to pause you every once in a while just so you can go back in there and re-solidify. Now, normally we would be joined by Mr. Lou Maresca. He is the second co-host of This Week in Enterprise Tech, but he is actually away for a noble pursuit today. He and some other Microsofters, Microsoft folk, are out building homes for the less fortunate. So when he emailed both Chibert and I, we said, of course, go do that. That is awesome. And we will welcome him back next week, hopefully with some tales of what it's like on the front line of social justice. Let's go ahead and jump straight into the blips. Now, bots, and more bots. If you follow the research on the increased use of bots in the enterprise, that might be your conclusion about the future of corporate-to-consumer interaction. Especially with the recent boom in context recognition, neural networking, and smart AIs, bots can theoretically provide much better information to consumers while dramatically reducing expenditures for our human customer relations workforce. Not so fast, says a new Forrester Consulting survey. The survey, which was sponsored by chatbot vendor Amdocs, surveyed more than 7,000 consumers across the Americas, Europe, and Asia, and found that 83% of consumers across the world prefer a human representative over a virtual agent. Breaking down the survey even further, 86% of respondents said that they had an interaction with a chatbot at least once a month. Roughly 40% said they find virtual agents to be faster or more convenient, but almost 50% admitted that even with the efficiency gains, they would only use a virtual agent if there was no other option. The main problem with chatbots is that while they work for basic information, they're still not advanced enough for complex problems, and they don't yet have a way to contextually analyze things like frustration. Still, this industry isn't going away, with chatbots predicted to save the enterprise $20 million by the end of 2017 and up to $8 billion by 2020. There is a huge niche available for vendors who can make a better bot.
Well, the Equifax breach has been talked about. But you know what? That Apache Struts vulnerability actually dated back to 2008. And, well, Equifax did drag their feet on it. It's an old vulnerability, but they still drag their feet. What's scary about this article is that they're stating nearly 65% of Fortune 100 companies are using struts on their website, and an unknown number are still vulnerable. The bug specifically affects a popular plugin called REST, which developers use to handle web requests like data sent to a server from a form a user has filled out. The vulnerability relates to how Struts parses that kind of data and converts it into information that can be interpreted by the Java programming language. When the vulnerability is successfully exploited, malicious code can be hidden inside such data and executed when Struts attempts to convert it. At the time of the announcement, there is no suggestion that an exploit is publicly available, but it is likely there will be one soon, the researchers said in their report. My biggest question is, why are there publicly facing web servers with access to such sensitive information and not better secured? Shouldn't even an IPS have found this attack? Makes you go,
Now, cryptocurrency in general and Bitcoin specifically is no stranger to volatile markets. In fact, it's just that volatility that has made some investors crypto rich, surging from $500 in 2016 to $5,000 just a few weeks ago. However, that volatility definitely has a downside in the form of highly speculative investments, and because of that speculative risk, China has just yanked hard on the blockchain. The Chinese government announced its intention to shut down all Bitcoin exchanges by the end of September because of concerns over the risks that the cryptocurrency market has placed on its economy. With initial coin offerings, or ICOs, on the rise and more startups using digital currencies to finance their projects, the Chinese government found the potential risk posed by market manipulation and just plain bad investing too great to allow. BTC China, one of the world's largest Bitcoin exchanges, announced that they will stop all trading as of September 30th. With other governments also looking closely at cryptocurrency, more than $60 billion of cryptocurrency wealth has been wiped out in less than 2 weeks. With Bitcoin sliding to a 5-week low of $2,972 this morning after hitting $5,000 just 12 days ago, then bouncing above $3,600 as of the start of the show, this isn't the end of Bitcoin or cryptocurrencies, with Chinese Bitcoin trading dropping to less than 10% of global volume after having instituted mandatory fees in January. But the loss of exchanges in China adds uncertainty into an already ridiculously uncertain currency.
Is crowdsourcing the future of disaster recovery? The people in Broward County, Florida, have one more map to rely on this weekend as Hurricane Irma passes through the state. MIT has launched RiskMap, a crowdsourced platform meant to track and map flooding by relying on people's social media reports as a pilot project. The county's residents can update the map by contacting its Twitter DM, Telegram, and Facebook Messenger chatbots. We were just talking about those. They'll then have to submit their location, a description of the conditions, and a photo showing its current flood level. Other residents and officials planning evacuations or sending help can then see those updates on the map as they go live. Tomas Holdness, of the MIT research scientist who led the project, says RiskMap shows the importance that citizen data has to play in emergencies. He added that by connecting residents and emergency managers via social messaging, their map helps keep people informed and improve response times. While it's unfortunate that the tool is only useful to residents of one county for now, the team aims to make it available to other locations and to add more social media platforms in the future. This is very much how a lot of scientists are enlisting the aid of citizen scientists to extend their reach way beyond what their grants could normally cover. We already have a huge network of folks that have earthquake sensors on their iPhones, and the Raspberry Pi-based weather stations being pushed by Oracle is already providing dramatically more detailed weather information closer to the users. I, for one, would love to see the maker community help make an even bigger impact on extreme weather across the world. This map that's being shown is one example of how publicly viewable weather cameras are blanketing the world.
No, we need something just a little bit different. Put this in your, hey, we deserve some fun news once in a while folder. AMD's Ryzen chips have been stoking excitement with their performance and price advantages over similar Intel chips, with AMD offering up to 16 cores on a chip and doing so at prices that make their competition almost halve the price on their top-of-the-line parts. The long-suffering chip manufacturer has seen its tech being used in everything from ultimate gaming machines to the enterprise desktop to the data center. Now, a French company wants to add AMD's parts for one more application: heat. Cornell makes a distributed cloud computing device called the QRAD that bundles 3 CPUs into a thermal transfer unit that can be located anywhere there is power and connectivity. The 3 CPU node provides cloud-managed power for jobs ranging from visual effects to big data analysis, but it also provides heat to its host. The French company has won a contract to equip 1,500 social houses in Bordeaux, France with the QRAD, which will heat homes with the waste from cloud computing. Carnot previously had created QRADs with Intel i7 CPUs, but as the AMD parts can provide twice as many cores with the same amount of heat, the switch to AMD will give the nodes a boost in the computing power that they can provide to the cloud. That does it for the blips. Next up, we're going to be jumping into a bite, a little deeper dive into the news of the week. But first, let's go ahead and take a break to thank a sponsor of This Week in Enterprise Tech. Now, let's face it, all of us have experienced data loss. I know it's kind of painful even for me to say it, but it's something that happens with regularity. A hard drive dies, or a storage device just can't be accessed anymore, or maybe we've just corrupted our data. Now, when that happens, we all have that moment of panic. Then maybe we start thinking about the last backup we made, the last bit of confirmable, usable data that we can pull back. But, you know, it's often a lost cause. Now, when the founder of Drobo had that experience, he decided to do something about it. So what he did was create something that could store your data forever. He created the Drobo. Drobo recently introduced the Drobo 5D3, which is their new third-generation 5-bay direct attached storage solution. With performance up to 2 times faster than the previous generation, it's the ultimate storage solution for media professionals, for content creators, and small businesses. The 5D3 has dual daisy-chainable Thunderbolt ports that can use lightning-fast Thunderbolt 3 technology to deliver blazing fast speeds, plus a USB 3 Type-C port for even more expandability. Drobo recently introduced the Drobo 5N2, which is the next era of simplified network-attached storage for your connected home or small office. The 5N2 provides high performance with an upgradable processor and port bonding capability via 2 gigabit Ethernet ports. It also features SSD compatibility, an MSAT accelerator bay, secure backup, remote data access and sharing, plus disaster recovery for additional peace of mind. Now, we've had Drobo here at TWiET since the beginning. It's what Leo used in the cottage to shuttle data back and forth. If we can trust our data with Drobo, I think you can too. Here's what we want you to do. Visit drobostore.com to learn more and to check out their complete line of products. Drobo has recently lowered prices on almost their entire line, and TWiET listeners can save an extra 10% off the purchase of select Drobo models, including the Drobo 5N2 and 5D3 at drobostore.com by using the code TWiET10. That's drobostore.com and use the code TWiET10. And we thank Drobo for their support of This Week in Enterprise Tech. Let's go ahead and jump into the bites. Now, this one is a little tricky because, again, we don't really want to get political. However, this is this interesting intersection between politics and technology and, of course, the enterprise. We very much appreciate tech here at TWiET. That much should be obvious. And the TWiET Riot is all about seeing new tech and new gear that can stretch the boundaries of what we think is possible in the enterprise. But one of the issues that pops up occasionally into our discussion of tech is where that tech is made. Now, with revelations of the past 3 years about equipment phoning home or doing otherwise suspicious behavior, the where of tech, where it's made, has become especially germane in the world of the enterprise. Now, more recently, the where has come into the spotlight because of jobs, and this discussion has culminated into Wisconsin. That's right, Foxconn in Wisconsin. Yesterday, in a 64-31 vote, the Wisconsin State Assembly approved an incentive package to lure Foxconn into the state. Foxconn will be investing $10 billion to build a factory. And for that investment, Foxconn will get $2.85 billion in tax incentives from the state of Wisconsin over 15 years. Now, let's talk a little bit about the factory. Here's what we know. It will build everything from TVs to network devices. It will initially employ 3,000 workers who are expected to make about $54,000 a year plus benefits. It could potentially employ up to 13,000 workers looking into the future. Now let's look at the finances. The Legislative Fiscal Bureau, which is a nonpartisan financial watchdog, calculated that assuming Foxconn hires all 13,000, not the initial 3,000, but 13,000 workers, and assuming that 22,000 extra jobs are created as suppliers and support businesses move to the area, then in that case, only then will Wisconsin taxpayers start to see a return on the investment of $2.85 billion in 25 years. So in 25 years, they could potentially, in the best case scenario, break even. However, there's an extra dimension to the story because this really isn't an investment. It's a bet. The proponents of the deal want us and want Foxconn and other companies to see the potential of basing businesses inside the heartland of the United States. They don't think of it as just a deal. They want this to be a template. The Wisconsin lawmakers want to make Wisconsin attractive to tech. Right now, specifically, they're looking to lure Amazon, which has announced that they are looking for a second headquarters that will employ up to 50,000 people into the state. And they see Foxconn as the start of a, quote, new Silicon Valley, unquote. So, Cheebert, again, let's try to keep the politics at a minimum. This is, depending on who you ask and where they land on the political landscape, either a huge, huge, huge deal that could potentially bring billions and trillions of dollars into the state of Wisconsin and jobs for tens of thousands of people, or it's a $3 billion boondoggle that in 25 years probably still will not have broken even. How are we supposed to judge this? How do we look at this? Is this a short-term deal or is this a long-term con?
So I really think what's happening is Wisconsin's taking a few too many pages from the Toyota playbook. When the car makers started moving into places, you know, down south like Tennessee, those plants had an almost immediate effect on the tax levy in Tennessee. All fine and good, but we're looking at it. We need to look at it a little differently in the case of Foxconn. There are a lot of smaller intangibles that need to flow in for this supply chain, but a lot of this is going to come from Foxconn already having relationships with supply chain. Building an electronic supply chain is a pretty big deal, and it's not going to happen immediately. And so 25 years, you know, that's a tough one. You know, that's a heck of a big bet for Wisconsin. And a new Silicon Valley is a tough one to do. And you know what Wisconsin's also forgetting is that the manufacture of electronics has had a pretty negative impact on Silicon Valley. I haven't heard anything about the environmental folks jumping in, but do you really want to have that much of a dirty industry? Foxconn's factories, you know, while very modern, still have an awful lot of byproducts, and I haven't heard any of that reaction from environmentals yet. From a tax point of view, I'm not sure this is going to be a win for Wisconsin because this is going to take a very long time. I'm not even sure 25 years is accurate. I think this is going to be a much longer tail on the return on investment. And I'm not sure the Wisconsin legislature is really doing the numbers on an apples to apples basis. I think they're taking way too many pages from what happened with the auto industry. And auto industry and tech industries are very, very different in the way supply chains work.
Right. And that's essentially what they're trying to do. They're trying to leverage the short supply chain. So they're assuming that having Foxconn in the state will draw together a lot of support businesses. That's where that 22,000 extra jobs number comes from. I should also mention, because this is being asked in the chat room, that the math for the Legislative Fiscal Bureau is available on the website. And essentially what they looked at is what would the tax revenue be? So the tax revenue off of 13,000 workers all making $64,000 a year, which, by the way, is already a stretch because all 13,000 will not be making that. And an additional 22,000 businesses and jobs from businesses that move into the state. They're looking at the tax revenue that would generate, and that's where they get the 25-year number. So in 25 years, they will get $2.85 billion in tax revenue from all of those additional jobs. Now, let me play devil's advocate. And actually, it's not even truly devil's advocate. I just want to represent the side of the Wisconsin lawmakers here. I'm thinking that most of them understand that the math on this deal is fuzzy. But what they want is they want to create a nucleus around which they can build that second Silicon Valley. Let's talk about that. It's not a bad idea. If you can attract enough businesses into one location, let's say they do get Amazon, let's say they get Microsoft coming in, let's say that they get a bunch of supply companies that can now supply to a second and third factory that might want to come into the state. Then that 25 years seems like nothing because you're also incorporating all those extra deals. However, Cheebert, and I think you were starting on this, the difficulty comes in the idea of the next Silicon Valley. We have become so used to hearing this. I heard it in pitches from PR agents from India and from different parts of Asia. We had the new Silicon Valley that was supposed to be developing in Las Vegas, the new Silicon Valley in New York, the new Silicon Valley in Illinois. And it's this idea that's not very well defined, but essentially new Silicon Valley means place where explosive growth is going to happen and we're going to make a lot of money. But can you buy your way into that, Cheever? Because the Silicon Valley phenomenon, the one that happened here in the West Coast, happened out of a confluence of wonderful things, just some brilliant people being in the right place at the right time, surrounded by the right companies. Can you just recreate that by buying your way into it?
You would think so. The way different governments are spending on it, you would think so. But a lot of them keep forgetting that Silicon Valley, one of the key pieces to that stew, was places like Stanford, having a lot of very, very talented people in one area. Now, no arguments that University of Wisconsin has some very talented people. You and I both have some friends at the TWiET lab at University of Wisconsin. Lots of talent, but is there enough talent? Silicon Valley is one of those weird places where there's such a huge concentration of talent that you have people that want to take a risk. That, do I take a okay job because the competition is so fierce, or do I roll the dice and try a new thing? And it's that environment, the world of risk takers that really and truly spawn Silicon Valley. Does Wisconsin have that? I don't know. I don't think so. New York thought they had it with NYU, and they were starting to pour some money into it. But Silicon Alley, which is what happened in New York, kind of fizzled.
Yeah.
And the one in Illinois kind of fizzled. Mm-hmm. India had a good run, but I'm not sure it really went anywhere.
Yeah, one of the things that we saw is in all of those places, and they made an honest to goodness effort in India, in Illinois, in New York, and they really did. They made the laws friendly to businesses. They gave a lot of tax incentives, and what they found was that the valley, the new Silicon Valley, continued to grow until they discontinued the incentives. And the minute they discontinued the incentives, they just scattered to the winds. And that was one of the lessons that we learned from trying to buy your way into a Silicon Valley, which is at some point it has to be self-supporting. And if you don't have a plan to make it self-supporting, then it just doesn't happen. You don't get that weird confluence of resources and businesses and intelligent people that you need to keep it going after you're no longer paying for them to be there.
Hawaii certainly tried it.
Oh, yeah.
It flopped badly. Now, JJ is asking about what is I think about Augusta. Well, I think Augusta is actually taking a very different tact. They're not so much trying for another Silicon Valley. They're trying for a cyber alley. So cybersecurity may be different. So I don't know. I don't think Silicon Valley is ever going to get duplicated. I think people are going to try. People like it, but I don't think it's going to happen because I don't think that confluence of resources, talent, and money is going to happen again.
Right. Okay, but let's talk about something else, and let's bring it back into something that we've covered on TWiET quite a few times, and that is the lament that so much of our equipment is built in other countries. Let's face it, it's all built in Asia. Everything is built in China. Everything is built in Taiwan. And that we've had stories in the past, horror stories, of really bad firmware, of preloaded malware, of devices that are not behaving. And one of the very small bits of talk that went into this deal was this idea of, well, what if we have a location in the United States where we could build secure equipment? I'm not sure if I actually buy that. Does that make sense to you? If Foxconn has a factory on U.S. soil, does that mean that we get more input and more transparency into how the device is actually put together?
Nah.
Yeah, that's what I thought.
We already have seen what happens, in China when Apple actually created an entirely new atmosphere of manufacturing in China. And Apple had a massive amount of input. But is it going to be any different in Wisconsin versus Sichuan? I don't think so. I think this is still going to be a who's signing the paycheck type of thing. And if we want more secure everything, we're going to have to make sure it's developed here too. And is it going to be different if it's manufactured in China versus the U.S.? Don't think so.
Yeah, yeah. I will say this. This is a developing story, and we will be able to cover this again as the factory actually starts to come online. It's a bold experiment. I have no idea if it will pay off. Good luck to those lawmakers. Good luck to the state of Wisconsin. This is kind of a test case. Can United States bring capacity, factory capacity, back onto our soil? Can we get the political will to bring jobs back? And does it actually have any benefit to the technology sector in general? I guess we will find out. Well, folks, let's go ahead and move away from the bite, because we're at that point in the show where I get to do my favoriteest thing, and that is to bring someone in who can drop knowledge on the TWiET Right. And ladies and gentlemen, I introduce to you Mr. Kevin Holder. He is the VP of Global Tech Services at Couchbase. Kevin, thank you very much for coming on to This Week in Enterprise Tech.
Thanks for having me. Happy to be here.
Oh, Kevin, for the folks at home who are playing along, what is Couchbase? What is the mission of your company?
Yeah, so Couchbase is a NoSQL database company. Founded in 2010. It was actually a merger between two previous NoSQL companies, one company called Couch1 and a second company called Membase, right? So the two companies combined created a very innovative product that has both a NoSQL database as well as a built-in cache and a persistence layer underneath that. So we are the database that runs inside many of the largest e-commerce websites, mobile applications that you probably interact with on a daily basis.
Now that's Couchbase, but you have a fascinating history. You've been working in this industry for more than 20 years. You've done everything from working with the gaming industry to the big data industry, the enterprise. You have a master's degree in computer information systems from Boston University. This was kind of your first love. You are a man who loves to organize information. How did that come about?
I love data. I started as a technologist very young, self-taught computer application programmer. But I got into the data business very early on in my career, and I've done a lot of work in data warehousing, as well as working with customers to deploy very large-scale databases on the operational side of the house as well. Right, data is something that really drives. If you think about it, it really drives our entire economy now. Right, so it's so critical to the way the economy works. And as businesses start to digitize and start to do more business online, start to go after, really collaborating with their employees and their customers and their partners, underneath all that is the data, right? And if your database is not performant, if it's not set up right, if it doesn't scale, nothing else will work, right? That's the persistence layer for your information, and information is really becoming, the key part to, operating a business at this point.
Oh, Kevin, there's been this interesting phenomenon over the past, I'm going to call it 6 years, where people actually believe that data only started becoming a big thing since Hadoop and big data, where the truth is the tech industry has been driven by data and by databases pretty much as far back as you can go. Why do you think there's this perception change of, oh, now data is important now, and all the other products just seem so unsexy?
It's because I think we interact with it on a daily basis now. 20, 30 years ago, databases were used for internal applications, within a company, right? Now, all day long, we're on the internet, we're on mobile devices, we book travel that way. We look up restaurant reviews with our mobile devices. And so we're interacting with data constantly, right? And so I think it's much more, front and center to people's mind. When you talk about data now, people know what that is. Whereas 20, 30 years ago, it was just something, well, yeah, we've got a database inside of our company somewhere. Maybe it's on a mainframe, maybe it's in a relational database. But it wasn't, kind of a key factor in people's lives. I'm very picky with my web apps and my mobile apps that I use. If I don't get a fast response time back I quickly move on to something else, right? Because I know if this screen load is going to be slow, then the next one will, the next one will. I don't have 15 minutes to waste here. And so people just expect a really fast response. They understand that it's data driven. And I think that's why, it's kind of more well known now than it was 20, 30 years ago.
Right. Actually, I would absolutely agree with you. I think the fact that everyone who has a mobile device now understands that data runs that device, that they have access to data from around the world, from pretty much all of recorded human history. Now they see the importance of data. It used to be just technologists and IT specialists who saw it. But let's talk about the world of technologists and IT specialists, because there's a secret that's not so much of a secret, and that is if you deal with databases on an enterprise level, 99% sure that you're dealing with SQL. SQL is the database. It is the 10,000-pound gorilla in the room. It is the life's blood of so many companies across our industry because it allows them to organize data. How did SQL, how did Oracle become so dominant in something that literally 20 years ago people really didn't care about?
I started my career in the mid-90s, right before the internet, and right as Oracle was really, starting to really change the industry, right? Prior to that, if you go back to the 80s, everything was on mainframe, centralized mainframe. A lot of research had been done in the 80s around, a relational database type of model that could be deployed to mini computers, microcomputers, as those started to come out. And then the SQL language was developed to sit on top of that to provide a easy way to access your information. And so there were a couple of things that were happening. PC technology got much more mature in the early 90s. Companies started to recognize, well, wait a second, maybe if we offload some of the processing that we're doing on our mainframe, we can save on MIPS costs. Let's put that onto newer, more PC-oriented platforms. And Oracle was there, at just at the right place, right time, with the right technology to take advantage of that, right? So a lot of organizations back then were literally in the process of understanding and trying to determine, how do we take apps that are on the mainframe and rewrite them as client-server applications using, it was primarily Oracle as the database at that time, right? So a lot of investment went into that in the mid to late 90s. And that's just, continued on. And then as the internet came out, the focus shifted, once again from client server back to, web-based applications. In the early days of the web, the relational database, scaled just fine to meet those needs. Now, what we're seeing is, still the relational database has a huge role to play, right? The transactions that occur are still stored in relational technologies. But what we're seeing in the market currently, and this is where Couchbase plays, is this need to not only capture the transactional data, right? If you're going to go on and to an online shopping experience, right? Literally, data is being captured with every click that you do through the website. And the data is not just being captured, but algorithms are being applied with every single click. And the more rich and personalized experience that an organization can provide to their customers, the more advantage they're going to have, and the more they're going to win in the marketplace, right? And so now, as you interact with a website, it's not just the transactional data that's being recorded and stored in the relational system. Now we're being tasked with we're capturing all of the interaction data, all of those clicks that are happening, applying algorithms to them on the fly so that we can serve up targeted ads or whatever the case may be, and required to return that within milliseconds back to the calling application. So definitely a place for relational still, huge out there. But on the interaction side, we're seeing really the NoSQL technologies really complementing relational databases to really help the organization scale.
Okay, so you gave us a very nice overview, but I want to drill down into that whole SQL versus NoSQL, because if there's one thing that our audience can take away, I think this should be it. If you were to try to explain to a CIO or a CTO the difference between SQL and NoSQL and when they should pick each one, what would that talk sound like?
Yeah. So the first thing I would say is, the term NoSQL has always been a confusing term, right? It creates confusion every time it's used. really what we're talking about with these two technologies is not so much SQL versus NoSQL, but really it's a discussion of relational databases versus non-relational databases, right? The relational database was developed, like we just talked about, back in the late 90s, late 80s, early 90s, and of course it's been enhanced and extended since then. But really, it's still a technology that was designed to support applications that would maybe have a couple of hundred users on them, maybe have several megabytes of data that would be stored there, right? What we're seeing with kind of the new economy, where everything is web-based and mobile app-based, and we need to track all the interaction data that I just talked about. The relational model was never designed to support that scale at all. What happened in kind of the late, the end of the last decade and into this decade was, some of the pioneers of the internet, people like Google and Facebook, started to realize, wait a second, we can only take these relational databases so far, and we're starting to hit volumes now where they will not scale. And so they started doing research, and kind of a lot of the NoSQL products that we know of today have roots that go back to those early research and development projects. So the non-relational kind of databases that are typically thrown into the NoSQL bucket are databases that are designed specifically to address the performance and scalability requirements of the types of web-based applications and the type of mobile-based applications that organizations are rolling out today. Relational databases are not designed necessarily to support that, right? You can scale a relational database, but it's incredibly expensive to do it because it's a scale-up model, whereas the quote-unquote NoSQL databases are all kind of based on a philosophy of scaling out horizontally, right? So we scale horizontally across commodity hardware. If a node goes down, we automatically fail over to another node. You can scale up your environment elastically as needed. So if you need to respond to things like, maybe you have an app that suddenly goes viral, right? Well, you need to be able to rapidly scale up your environment to support that, right? The relational model is not real effective at that. NoSQL is designed to do that. You'll also have certain peak times throughout the year. Maybe Black Friday is another example, right? Where you're just going to get pounded. Your retail systems and your web applications are going to get pounded. So you want to be able to, scale up your environment to support that, but then scale it back down so that you don't have to carry that heavyweight, architecture and infrastructure all throughout the year. So that's kind of how I would look at it.
Okay, that's great for the CTO or CIO, but now let's bring it down to the engineer level, because this is our audience. They're very savvy. This is what they want to hear. Let's take two applications, and let's just assume that they're the same. They're massive cloud-based applications. We all know that relational databases have trouble scaling because, as you mentioned, the architecture, the actual architecture, how the data is laid out, does not lend itself to massive I/O. It really starts to bottleneck once you get more than a couple of hundred or a couple of thousand users. How would I scale that up? So if I had a relational database, let's say I have a legacy database, and I have to just keep making it bigger and bigger and bigger because my company grows bigger and bigger and bigger, how would I do that? Versus, how would I do it if I had started with a NoSQL database? In other words, what does my scale path look like for the two examples?
Yep. So with the relational model, you've always got to plan your infrastructure around whatever you think your peak volume will be, right? So if I anticipate I'm going to have, X amount of volume to support a Black Friday, I better plan my entire infrastructure to support whatever that peak is up front, and then deploy that, and then I'm kind of tasked with maintaining that, going forward. So really, in the relational world, it's about trying to understand your data volumes, what your data volume growth is going to be over the next, 12, 18, 24 months, trying to, create, server sizing so that you can support whatever your peak may be later on, right? Because once you kind of lay down the infrastructure, then you're going to work with that infrastructure for quite a while. So you got to it's more about planning ahead and trying to understand. Downside to that is now you've got a lot of server capacity that is really sitting idle for most of the time because you've had to really size that for your peak moments, right? Now on the NoSQL side, because we scale horizontally instead of vertically, right? So what I just described with relational is vertical scalability, right? So we increase the size of servers in order to add more capacity. With the NoSQL model, we don't increase the size of servers. We just simply increase the number of servers that we have in our cluster, right?
Right.
And I can speak to our product. Our product is designed to, through our web-based user interface, you can easily go in and say, I need to add a new node to my cluster. You can even script it out, and it's, can be automated. So adding additional nodes to your cluster is very easy to do, and then we automatically shard the data across those nodes. Then we'll rebalance it out, right? So, you don't have to sit here with a lot of idle, hardware capacity like you do in the relational model, because you know that, okay, before Black Friday, we're going to expand the cluster to this, and then we're going to, scale it back down. So really it comes down to vertical scalability, adding bigger boxes with the relational model versus the horizontal approach of just being able to add additional nodes to your cluster as needed to add processing capacity whenever you need it.
Right. So for the relational database, for the SQL database, essentially as that database gets larger, every box that I add has to be able to handle the entire instance of that database as it serves out more clients. Versus the shard view, and the shard view is every box I spin up only has to maintain its particular piece of the puzzle. It's shard, and I can just increase the number of shards rather than increasing the complexity of the boxes the shards run on.
Exactly. And with our product, we automatically shard, so you don't even have to think about the sharding itself, right? That's all handled under the covers for you. Just to share some numbers with you, a couple of our customers, eBay, for example, eBay is one of our largest customers. We're embedded within their mission critical architecture that drives the eBay website that you purchase on. That website alone gets 2 billion page views per day. And that translates to 80 billion calls to Couchbase every single day. And so to support that, they're running actually 1,400 servers of Couchbase in their environment, storing 60 billion documents, and it's about 90 terabytes in size. And then their peak gets and sets are about 1.2 million to 800 a second within a single cluster, right? So, those numbers, again, when the relational model was designed, no one would have ever dreamed that we would be hitting those types of, volume numbers, right? But that's what an organization like eBay, has to support, and that's where really, leveraging the NoSQL technologies and that architecture really becomes, absolutely critical to being able to support that and to do it with consistent performance and reliability and everything else that goes along with it.
All right, I need to bring in my co-host back into the discussion in just a bit, but before we do that, I want to give you a chance to give me a hypothetical situation. Let's say I'm a growing startup and I'm in a relational database right now, and I've just recognized we're growing too fast to continue this scaling model. At some point, we're going to have to bite the bullet, go through the big pain, switch to NoSQL or to a non-relational database, some sort of flat database. And what can Couchbase do for me? So if I were to come to you with this problem, what kind of solution could you present?
Yeah, I'll give you more than a hypothetical. I'll give you a real customer example. Pokemon Go. Pokemon Go.
Oh, yeah.
Before they launched, they had initially started building their application using a MySQL database. And through some of their initial testing, they kind of determined that, they didn't think the relational model was going to work. They came to Couchbase and said, what can you do? So we deployed a team on site for them, and we were able to, model their data, right? So the first step is model your data as JSON document objects as opposed to relational database structures. And there's, well-defined best practices for doing that. Slight modifications to the application layer. The nice thing about Couchbase as a product is that we do actually have a full, very mature SQL language, right? So even though we're a NoSQL database under the covers, we actually expose to developers a SQL language that they can use that is actually ANSI SQL standard. And so between the combination of those things, we were able to very quickly move Pokemon over to the Couchbase architecture. Now, when they did their initial planning, they planned a cluster size that they thought would support about, 10x they thought their cluster size would support about 10x of the volume that they expected. What happened was it went viral in a crazy way that they never expected.
Right.
And the initial cluster size that they had put together was nowhere near what they needed, right? Luckily, they had gone with Couchbase because they were able to add additional nodes, both for the data service as well as the query service, and scale the thing up on the fly without really any downtime at all. So that's a very specific example. To your point, that is actually what happened with Pokemon Go.
I had no idea that Pokemon was originally running on a relational database, but that absolutely answers so many questions I have about the initial crash. If I'm sure at some point someone said, look, the server farm that we've bought can handle 10x what we think is going to happen. Once it hit that 10x, there was no easy way to grow past it.
Exactly.
Because you're in a relational database, it was like, well, there's no bigger boxes we can buy. How long did it take to switch from that to a NoSQL infrastructure?
We did it very quickly. I think we had a team. Obviously we parachuted in a team on site from our services organization and helped them go through the switch. It happened over I would say a couple of weeks probably is how it happened. But the initial we were able to resolve the initial problem with their scalability issues very, very rapidly, and then scale up the environment from there.
Right. And actually, Specs in the chat room has a good point, and that is, so once you switched over, where did all the extra nodes come from? How do they draw on additional computing power to spin up new shards as the demand increases?
Yeah, so spinning up a new node is fairly straightforward these days, right? A lot of people are using container Docker type technologies to bring new nodes online. I'm not sure exactly what Pokemon was using from an infrastructure perspective, so I'd have to kind of defer that question. But for the most part, things are virtualized and cloud-based, these days, right? So spinning up new nodes on, Amazon or Azure is, a matter of clicking some buttons, and then adding those nodes to the Couchbase cluster is a matter of clicking some buttons as well. And all of those things can generally be scripted, right? So, the idea of auto-scaling an environment is something that's, very, very common these days.
All right. Let me go ahead and bring my co-host back into the discussion. Cheebert, first of all, sorry you missed out on the discussion about Pokemon Go, because I know you are a huge Pokemon Go fan. You're level 40, right? Do you even have Pokemon Go installed on your phone?
No.
You should. There's some unique Pokemon in Hawaii.
Okay, sure.
Okay, now let's get back into the database questions.
Yeah, so from an operational standpoint, we've got a lot of conversations about changes. We hear about changes in this, changes in that, containerization. I would like Kevin to just stop and think just a little bit. This is a total pie in the sky opinion question. From an operational standpoint, so say you can actually affect Dell and IBM and HP's product lines, what would your suggestion be to them? Because I don't think the hardware is quite keeping up with the software at this point. What would you like to see happen in the hardware world and for operational standpoint?
That's interesting. We don't... Because we're designed to scale on commodity hardware, we don't necessarily, have strong opinions on that. Now, we have optimized, the way we work with SSDs, for example, to read and write from SSDs to be more effective. But, outside of that, I would kind of defer to, the customers and the hardware vendors and kind of, want to know a little bit more about, where they're going and where they think they can make some improvement there.
Well, okay, then what's missing? Has there been any kind of roadblock that you wished wasn't there? Well, other than the speed of light,
It really comes down to, physics, the laws of physics. Obviously we can never have enough networking bandwidth, right? We always, consume whatever's available. So, as networking technology continues to increase, that's a factor. Because we're deployed on a number of nodes inside of the data center, the way the network is set up is very critical, right? And then we also have the ability to replicate data across data centers, right? So if you have two geographically separated locations, we can replicate data from there. So occasionally we'll run into network saturation type situations where the network just simply can't keep up with what we're doing. So that might be one that I would point to.
Kevin, let me ask you a question. Does your solution give itself to geographically balanced distributions of nodes? For example, if I have a global spanning enterprise with data in different pockets around the planet where they are most often accessed, do I have to replicate across all my large data centers, or is the solution intelligent enough to pull from that remote node, that remote set of nodes, whenever it has a request that isn't often found in my geographic location?
Yeah, so we have active replication inside of the product. We also have filtering on replication as well, right? So you can choose to replicate the entire data set across, or you could choose to apply filters to it. But what we're doing on the back end is making sure that the data, whatever your replication rules are set to, we're making sure that that data is replicated, to the other nodes or to the other data centers as quickly as possible. Now, the scenario that you described, where maybe if my data is not available, let me go to another cluster in another data center. That type of logic is typically built into actually the application layer as opposed to what we're doing on the back end. We do also work with customers who want to ensure that data is geographically located close to certain users, or certain customers, right? So, part of the modeling design and laying out their replication architecture is to try to understand, okay, are you, do you want to have a subset of data in each data center that is, closer to the users? Do you want to have all data that's available? Do you want to have an active passive type of environment? So there's a lot of various different ways to slice that, and our technology is built in a way that we don't get in the way of that, right? The other thing about the replication technology that we have is we use the same core engine component and protocol for all replication within our product, right? Whether it's across to another data center, whether it's from one node to another within the data service, or whether it's from the data service nodes into an indexing node, for example. So everything is built on this data change capture protocol. We call it DCP, and it's memory to memory replication. So extremely low latency movement of data. And so when you write to a Couchbase node, instantaneously, that data is replicated to another node within the cluster for failover purposes. And then if you have cross data center replication, it's set up and within milliseconds replicated to the other data center as well. So a lot of times, like I said earlier, really the thing that gets in the way is sometimes the network bandwidth.
Okay, so Kevin, I teach. I work at a university. For my students that are listening, and hi JJ, how are we going to get started? Is there like a small version that a student can grab for free that maybe has some sort of limits? But just how do I eat the learning curve for, say, kids or oldies like me that, my big training was in database, for God's sakes, on CICS.
Yep. Now, you can actually download the Enterprise Edition and use it for free for development and test, right? So it's not even a limited edition. Our Enterprise Edition is what I would recommend that you download because it's going to have all of the features built into it. The download page is available on Couchbase.com. You just go in there, you click it, it'll prompt you to enter an email address, and then you download it. The only restriction around the Enterprise Edition is that you cannot use it in a production application without purchasing a subscription license from Couchbase. But for your students, as you just described, they're not running production applications. They're learning how to do development. So I would point them to the Enterprise Edition because it's going to have all the features in there, and it's free for development and testing.
Kevin, I have to throw this question in here just because we do have several very vocal fans of open source, everything open source in our TWiET Riot. And they'll look at the Couchbase solution and they look at SQL and they basically see them as the same thing. Oh, they're closed solutions, so therefore I can't trust them. I mean, it's always difficult to make points against someone who is fanatical about their support for one infrastructure or another. But how would you address that? If someone were to come to you and say, is it possible for me to cobble something together with open source to do what it is that Couchbase does, that NoSQL does? What would be an honest discussion with you? Not adversarial, but an honest discussion about the state of the technology.
Well, the reality is Couchbase is an open source product, right? So also on the download page, there is a community edition that we provide that can be downloaded for free and actually ran in production free of charge. The only caveat with that is it does not contain all of the features of the enterprise edition, right? So there are just certain things that we have built for enterprises that we want to make sure that we monetize. But we are open source from that perspective. We're also open source in that our code is available out there on GitHub, right? I would not really encourage anybody to try to go modify it or play around with it, because you don't need to, right? You can grab enterprise edition free of charge, or even community edition, depending on what you want to do. So we are an open source product, actually. We do have a community. We have a specific dedicated part of the Couchbase organization that is focused on the developer community, and kind of making sure that we don't lose our open source roots. So we are an open source product.
I think that will help some of the fears, but of course there's still going to be people who say, no, it can't be open source because I can't download everything and I need the full product forever and ever. But fantastic.
Yep.
Kevin, we are running out of time, unfortunately. I could go on forever. I love talking about scalability. I love talking about new ways of looking at how we spread out our data. But I do want to give you a chance to make your pitch. If there's someone out there who's looking at potentially migrating their relational database, or if there's someone who's currently running a flat database and maybe needs help, needs to look at a better way to create a solution, or, as TWiET mentioned, if we have students in our TWiET Riot who are looking about where they can start this, if they wanted this to be something that's in their quiver, where do they start learning?
Yeah, I would say first step would be to go to Couchbase.com. Go ahead and download the Enterprise Edition. There's no penalty for that. It's got all the features that you'll want. There's also tons of documentation, resources, blog posts that are available on the internet. We have forums that the folks can access free of charge to get questions answered as they're starting to learn. There are books that are published that are available. But I would say the number one thing is download it. When people download the product and install it, they're typically blown away by how easy it is to get it up and running. I mean, within 5-10 minutes, you've got a NoSQL database up and running on your environment, and then you can go from there. So that's where I would start. We also have information out there on Twitter. Go check out our Twitter feed at Couchbase on Twitter. There's lots of good resources out there. We also have, obviously a presence on Facebook and on LinkedIn. So there's groups that you can join as you start to work with the technology and get up to speed with it. Everything's out there on the web. It's a matter of, just don't be afraid of it. Download it, get your hands dirty, and it's a really, really fun product to work with.
Get your hands dirty. I don't think there's ever been better advice than that. We've been speaking with Kevin Holder. He is the VP of Global Tech Services at Couchbase. If you need to know about what's happening in the NoSQL world, they might be a really good place to start. Again, Kevin, thank you very much. Let me give you one last plug. If they want to find out about you, where should they go?
I've got a Twitter at Kevin1Holder on Twitter. I'm obviously also on LinkedIn as well. So just look me up, Kevin Holder, on LinkedIn. And that would probably be the best place to go.
Fantastic. Kevin, again, thank you for being part of this episode of This Week in Enterprise Tech.
Thanks for having me on. Really enjoyed it.
Folks, you've done it again. You've used up another hour listening to the best dang enterprise podcast in the universe. That's according to 9 out of 10 relational databases. We want to thank everyone who makes this show possible, starting with my good friend, Brian TWiET. I thank you for sitting in the heat every week and fanning yourself in between camera appearances just so you can share your knowledge with the TWiET Riot. What are you up to, and where can the TWiET Riot find you?
I am ADVNETLAB on Twitter. It's a little cumbersome, but it's Advanced Net Lab. And for people that have been asking, I've been making noise about retiring. The Advanced Network Laboratory is not going to die. In fact, I just had a verbal agreement from some of my ex-students that are teaching at Leeward Community College. It looks like Ankle is going to move to Leeward.
Ooh, you're going to get some new background there. Does this also mean that I can come over and visit the new campus for research purposes?
You bet. And, set foot on campus, you're going to be teaching a class, buddy boy.
Oh, man, no. Can't do that. Sorry. Not since the incident. G-Bird, it's always great to have you on. And, I wouldn't want to do TWiET without you. Now, Lou Maresca will be back with us next week after building homes for the less fortunate. And so you can look for us to be back to full strength in the coming week. Also, I want to thank you, the people who come back each and every single week. We couldn't continue to do this show if we didn't have an audience. And you have been wonderful about trying to use us as your source for enterprise goodness. We want to make it a little bit easier. You can just go to our show page at twit.tv/TWiET. There you will find all of our back episodes. If you want to find a story that we talked about or the contact information for a guest, it's all right there for the taking. And as long as you're there, why not subscribe to the show? We've got a little drop-down menu so that you can get an audio version, a video version, or a high-definition video version into the device of your choice. It's the best way to support TWiET and the best ways to spread the news about the TWiET riot. Also, don't forget that you can find me on Twitter at twitter.com/PadreSJ. If you follow me, you can find out what I'm doing both in the Twitch studio and when I'm out and about, like playing with Pickle Rick or finding new pancakes at IHOP. It was an experiment. That was an actual academic experiment. Again, go to twitter.com and subscribe to PadreSJ. Finally, thanks to everyone here who makes this show possible, to Lisa and Leo, who have allowed us to continue doing TWiET all these years, to the tech staff, the engineers who hook everything up and push all of our buttons, and to RTD, who today is going by the name of Shark, because we have Kevin as a guest. Shark, normally at the end of the show, we ask you a question to give you a chance for redemption. Are you ready for your question?
I was born ready.
All right. Well, we know that you love sharks, and we know that you love Pokemon. So if we are going to try to scale Pokemon, can we use a relational database along with some huge clusters from, say, Amazon or Google to scale up to a festival-level event, or do we need to go with NoSQL from Couchbase?
NoSQL.
Oh, no, I'm sorry. The answer was a lightning stone. That's what's required for evolution.
Thunderstone.
Whatever. I'm sorry, but you can
or
never
lightning.
be right.
I forgot.
Until next time, I'm Father Robert Ballister, the digital Jesuit, just reminding you that if you want to know what's going on in the enterprise, just keep TWiET.